So welcome to this talk on the future of machine learning and JavaScript. My name is Asim Hussain. You can find me on Twitter as Jawache, not Joashe, Jawache. I blog about Angular and JavaScript, and hopefully soon I'll find the time to write about machine learning on my website, codecraft.tv. And I'm actually a cloud developer, a cloud advocate, we call ourselves now, at Microsoft. In fact, I've just had a promotion. I now lead cloud advocacy for EMEA, which is a big region. And so this is us. If you want to go find out the other cloud advocates at Microsoft, you can go to that link there. We are the advocates who work at Microsoft on our cloud platform, Azure. And we're the people who talk about open source technologies with the Azure cloud platform. And there's people, all different skills, JavaScript, machine learning, containers, anything. You can find us all there, and you can connect with us on mainly Twitter, but other sites as well. I also, I work with a charity called the PAL Internship, or the Palestinian Internship Program. And what they do is they help find Palestinians internships at high-tech Israeli firms and startups. I mentored 10 of them last year. And this year, I'm very, very proud to say that mentoring 10 people as one person was very, very hard. And this year, I'm very glad to say that 17 of the interns this year are going to be mentored by one of those cloud advocates. So if any of you work with or at a high-tech Israeli startup, and you have maybe places for interns, you want to find out more about it, come give me a shout. I'm an instructor on Udemy. I've shown this slide so many times. It's still as funny. I'm an instructor on Udemy, the teaching platform. Anybody here my students? Thank you very much. And last year, they added in automatic subtitling. And they correctly spelt my name as Awesome. My name is Awesome. So for the longest time at work, I changed my handle on our instant messaging platform as Awesome. So they had to go, "Hi, Awesome." And I loved it because someone has to call you Awesome to get your attention. But my boss at the time then said no. If you look at my journey over the last year, it's been something like this. So this is a meme. I got in trouble with this before. This is a famous meme, so it's not just that. But this has been web development, Asim, machine learning. This is a slide I stole from my friend Eleanor Haproff. So Eleanor and I go back a very long way. And start of last year, we were sitting in a bar getting drunk, and we were talking about machine learning. We were talking about JavaScript. Some things had just been released. Some things was getting a little bit exciting. We thought, why don't we create a meetup in London and start talking about it? And that's what we did. We made a meetup in London called AI JavaScript. And we've run like so many meetups now. It's very, very popular. I think we're one of the fastest growing meetups in London. We've just reached 1,600 people. But what would happen at the end of every single one of our talks, somebody would come along and hand us, "Oh, here's an interesting little application somebody's built. Oh, this is interesting. Why don't you get..." He's not going to get the prize. Bag full of money. He kept on giving us links to here's interesting applications that are using AI and machine learning and are JavaScript based. Why don't you? Here you go. And we've got so many of these. We said, well, why don't we make a website that celebrates, that shows people each of these different applications? And that's what we built as well. We created a website called AI.js Rocks. And if you go to this website, you'll find a whole list of AI-powered JavaScript applications. And because they're JavaScript, it means that you can click on it, you can play around with the browser, you can get inspired. Also, because it's JavaScript, it usually means you can kind of view source or just examine it and see how it's working. There's also GitHub links, so you can see the source code itself. And just learn how it works. And I found this to be one of the best ways I've learned about this field is by seeing a demo, seeing that looks incredible. How do they build it? And then going into and understanding that has helped me really understand a lot of the stuff in this space. How am I supposed to drink this? And so what we're going to do today is I'm going to talk about three different applications that are on AI.js Rocks. I'm going to explain what the application does, and I'm also going to explain how it works underneath. And so hopefully, as you go through today, as you go through this talk, you're going to understand a little bit more about machine learning and JavaScript. And at the end, you're going to have a kind of a good overview of what's possible with the different technologies and also how to learn more. Now, the first application is called the Emojifier. Okay? It's not trademarked. It's just the Emojifier. So I thought it was a funny thing to add at the end. And this is what I made. I made the Emojifier. And I'm very proud of it because I think the Emojifier is going to change the world. I really do. I really do. So what the Emojifier does is you can give it a picture of someone's face. Okay? It then detects that it's got a face. And then any guesses?
Make emoji. Find the best emoji.
Yeah. There you go. So what it does is it finds the emotion associated with the face, the emotion, and then matches it to the appropriate matching emoji, replaces it on the face, and puts it in the image. Yeah.
Change the world.
Yeah, change the world. Yeah. Thank you. Thank you. That's the first round of applause I've ever had for this. But it's had many different incarnations. The most recent one is as a Slack bot. So you can actually go to theemojify.com, click the Add to Slack button, and it will add it to your own Slack workspace if you use Slack at all. And it's all written in JavaScript and TypeScript, actually. And this is it working. So you can do a couple of things. This is a picture of my son. There he goes. And what does he look like? You do type /Emojify, an image. Yeah, that's about right. It can handle multiple people in an image. Emojify, there you go. Yeah, about right. And I've answered a question that has plagued artists for years and years and years. Yes, that is the Mona Lisa smile. It is. She's not smiling. Okay, there's a lot of things that are happening inside this application, a lot of different things. There's a Slack bot, there's APIs, all kinds of things. But I think the most interesting thing for this talk is, how does it calculate emotion? It's kind of crazy. How do you calculate emotion of a face, right? And it's very easy. It's actually very, very much easier than you think. It just needs two steps, just two steps. The first step is to detect the facial features. So now it's 2019. We all know, we've all figured out the exact facial features that you always need, that every single face has, every single person, well, maybe not every single person, but lots of people have the same facial features. And through the examination of these facial features, you can figure out who somebody is and also perhaps their emotions. So that's the first thing you need, is to detect the facial features. And there's loads of different libraries that you can do to get that. You don't really need to use machine learning. There's lots of computer vision. There's just pure algorithmic methods of examining an image and finding out the facial features. And there's one link you can go and find out how to do it. And that's the first step. Just know where the different facial features are. The second step is super easy. You just have to use a neural network. So just those two steps, facial features and neural. Do you need me to explain a neural network? Yeah? Just for you. They all know what's going on, but just for you, I'll do it. Okay. So a neural network has a basis in biology. Okay, so it's based on real neurons that exist in your head. So a neuron in your head has these things called dendrites going in, a body, and some axons going out. If enough electricity goes in via the dendrites, the body goes, that's enough electricity. I'm going to fire some electricity out through the axon. That's it. That's all that happens in a neuron inside your mind. You have at least one of these. Okay. Maybe after tonight's after party, you will have 0. I don't know. But if I asked you, okay, now code this up in JavaScript, I would have to remember back into my computer science very first lectures or the very first things I've ever learned on graph theory, and I couldn't remember it right now. But if you try to code something up like that, you'd probably go, I need a node, class node, something like that. Some edges, fancy graph theory. I scored 20% in that module. Edges going in and one edge going out. And then you need to put electricity in. What is the electricity? The electricity is the features of perhaps an image or the features of what you're trying to make a prediction of. So perhaps it's the day of the year, so 23rd day of the year, and the temperature. And you're trying to figure out, okay, how many, what do you call those things? The little insects that make sounds. Say it. Crickets. Can't believe I forgot that. And you're trying to create a neuron which kind of guess, given these two inputs, how many crickets are going to be chirping, or the decibels of crickets chirping. That's the inputs. What you do with your neural network, your single node, is each edge, you initialize it with a random number, just a random number. Okay? You multiply these two together and you pass it through an activation function. All that does is just passes a number back out. Just a function, you pass in a number, it returns a number. And that's it. Maybe there's only one cricket chirping in that situation. Just to explain it a little bit more mathematically, it's like this. This is all you're doing in a single neuron. Some input values. These are your weights. You multiply them by your weights. You add them together. You pass them to an activation function, and wherever the activation function returns, you pass that back out. This activation function is a really simple activation function. It's anything below 0 is 0. Anything above 0 is 1. There's many different types of activation functions. You have to know which ones to use for given data sets. And that's it. You combine a number of these together. You just combine them together. So this is a 4-layer network. One input, one output, 2 hidden. And you initialize all of those edges with random numbers. That's all we've done. Initialize it with random numbers. And then you get the data set. So you have a data set of, this is a supervised machine learning, you have a data set that you've already figured out information about. So you've got a data set of images, you've already calculated the facial features, and you already know the emotion. You already know, you have to know the emotion. A human being probably has gone through all of these images, thousands of images, and said what emotion it is. Okay, so you know the emotion, you know what it's supposed to output. You take those facial features, they're the electricity going in. Then you just multiply, it's just multiplication. Maybe a little bit of addition. No, not much addition. A multiplication all the way through until it comes out with a number. When I do a machine learning workshop, and when I get to this point, everybody's like, it's just multiplication? And yeah, it's just multiplication. A lot of it is just multiplication. Okay? When I first started doing these things, I tried to put if statements in there, and my colleagues who really know machine learning just look at my code and go, this is not mathematics, Asim. You can't do that. And so yeah, a lot of it's just multiplication, and it's things you can derive from. But the thing is, this neural network came out with 3 with this image. But we know this image is 8. Maybe 0 is unhappy, maybe 10 is happy. We know, because a human being has said, this person's 8 happy. So we know that this neural network is wrong. Of course it's wrong. We initialize it with random numbers. It's not going to suddenly get it right, is it? It's wrong. How wrong is it? It's wrong by -5. what we do, the kind of magic that goes on in machine learning is the learning, the training. And the training is the process of adjusting these weights so that when you pump these values in, it gives you 8. We know it's wrong by -5, so we use something called back propagation. And that's an algorithm which, given how wrong it is, knows how to change those weights so that the next time you run it through, it gets a little bit closer. And you do it again and again and again with the same data. Again and again, the numbers change very, very slightly until eventually it's trained up to a point where it's giving you 8. Uh-oh. I have to go through all those animations again. I'll repeat it all. No, you train it all the way through until it gives you 8, right? And then you know it's done, it's pretty much trained, this neural network. That's what's going on. It's just the process of it's just these weights that you randomize initially, and then it tunes them until it gets better and better. That's all that machine learning is, okay? That's what you could use. And in fact, you can actually train up. There are data sets out there publicly available, thousands of images that somebody has figured out the exact emotion of that image, and you can train this up yourself. And lots of people do that. It's a good way to learn about machine learning. I didn't do that, though. I used an API, okay? Because there's lots of different problems like this, especially problems that are so common that they're applied for, that they can be used for everybody out there. Lots of different cloud platform providers have made available these APIs. Google has, Amazon has, and so have we. And in Azure, it's called a face API. So it gives you a ton of information for an image, not just the emotion, a whole bunch of information. And I have had a word with the marketing team about changing this image, because I think she looks a little bit too confused. I think it needs to be somebody who's like, something like that. So anyway, that's the face API. And it works very, very simply. You can pass it. The image can be passed as binary. It can be passed as anything. And then you pass it to that API, and it gives you a bunch of information as a result. Not just this. This is just a subset. It's very large. Everything. The exact location of a pupil on the image. Lots and lots and lots of different information. But here it gives us an array. Each rectangle that is detected a face in the image, and the emotion 0 to 1 for anger, contempt, disgust, fear, happiness, neutral, sadness, and surprise. Who here has a beard? I see you, sir. I saw somebody there. Put your hand up. Go on. Go on. Yes. Not many, actually. Oh, wow. Oh, yeah, you there as well. If you have a beard, you cannot be 100% happy. It's impossible. We can't be. We can only be 99% happy. So, you as well, sir. There you go. There's a 99% happiness right there. So, and that's what I used to build Emojifier. So, just to summarize, neural networks are incredibly powerful. When we talk about machine learning and the advances that have happened over the last 10 years, it's with advances in the neural network algorithms that we're using, that include the back propagation one especially. And computing power, right? So a lot of this stuff requires a lot of computing power. And this is last 10 years or so. This is where the real changes have happened in this space. And conceptually, they're very easy to understand. I've explained it in 10 minutes. 20 minutes. Oops. I've explained it in 20 minutes how they work. Okay. And I have to move on to the next one really quickly. So that was the first application. This is the second application. And in one of my workshops I gave in London 6 months ago, a few days after the workshop, one of the attendees then sent me this. And it's like, I built something based off of the contents of your workshop. And I was like, yes, that's what you want, when your students build something and sends it to you. And this is it, basically. So it's a code pen. And this is doing a search on Unsplash for the term. So it's searching for I'm fine or puppies. And it returns that image. And it tries to figure out what's inside the image. So this one is searched for I'm fine. And Didn't get it very right. But this one maybe is maybe it's a fountain. You don't know. Could be a fountain. Some bubbles. It has got bubbles, and it has a dog in it, so it's kind of okay. I think that the next one actually does look okay. So this one, yeah, T-shirt. Okay, so it's figuring out what's in the image, kinda. So, and the important thing about this demo is the only API that's being used is the API to get the image. The actual detection of what's inside the image is all happening in JavaScript in the browser. Okay, all happening in JavaScript in the browser. How does it work? It uses a technology called TensorFlow. Does anybody know TensorFlow? Anybody use TensorFlow? Oh, a few of you in the audience. They're the ones who are. If you've got any questions, you can ask them at the end of the talk. So TensorFlow is a technology that was open sourced by Google in 2015, 2016, something like that, and it allows you to run calculations across tensors, and all a tensor is a multi-dimensional array. So a lot of matrix kind of multiplication across lots of CPUs, parallelize across a GPU, your graphics card on your computer, and lots of graphics cards and lots of computers. That's what TensorFlow was built to do, and it's very, very good for training neural networks. Okay. But then, just over a year ago, they launched JS. Don't you love it when they put a .js after things? Then you know, yeah, we're going to take over now, aren't we? So TensorFlow JS. Now, when I first heard about TensorFlow JS, I thought it was bindings, like node bindings for TensorFlow. So you had to install TensorFlow, which is like a big C application, in order to use TensorFlow JS. But no. Here's the thing to know about TensorFlow JS is it's TensorFlow completely rewritten in JavaScript, ground up. Okay, what does that mean? It means in order to do machine learning in Node or the browser, this is all you need to do. That's it. Drop a single import statement, or if you're like me, I like my script tags. I still use script tags. Or use script tags. And it works in the browser or Node as well. In Node, it does have dependencies. In Node, it actually does install TensorFlow. So the Node version of it will run a little bit faster. But the browser one is all completely rewritten from the ground up, so it won't install TensorFlow. And you can do lots of things with it. So you can do what I described to you just before. That whole process of creating a model, giving it some data, training it, back propagation. That whole thing you can do in TensorFlow JS. That whole thing you can do in TensorFlow JS. The other thing you can do is you can load pre-trained models. So once you've trained a model to do something, maybe like the one before where you trained it to detect emotion, you can save it as a JSON file, and you can load it with tfload model. Again, the browser or Node, doesn't really matter. And now what's happened after a year, people have started to create lots of pre-trained models which you can find on the internet and start using. And you can also take something that's been built using TensorFlow on Python on thousands of servers and trained there, and there's scripts now that convert it into this JSON format so you can use it from JavaScript. There's lots of different sources for it. What Oliver used, who made that demo before, was he used something called MobileNet, which is available online. It's a pre-trained model. This is just a wrapper to it. But basically, this is all you need to do in order to do that. So get an image, load the MobileNet model, which is going to load a JSON file, okay, off the internet. And then you give it the image. You call it classify. And it gives you those predictions, so that array of percentage and what you think it is. That's all you need to do. That's it. 1, 2, 3, 4, 5, 6 lines of code to do prediction of an image in a browser. Pretty cool, right? Yeah? 10 years ago, we couldn't detect the difference between a cat and a dog using kind of beefy servers. Now we can do all this kind of stuff in the browser. That's what you can use, but MobileNet you saw, it wasn't really that good. okay? It was okay. It was a little bit okay. Like, it told you some things, didn't tell you other things, right? And that's because the word mobile, it's been optimized to be small enough to be mobile friendly, okay? So still quite a few megabytes. It's not really something you want to normally block rendering of a page for or something along those lines, right? Maybe if you're doing something with Node.js, it's already packaged as part of it, but it's very, very large. But to do even more accurate image detection, you have to use a much, much, much larger model. These things aren't possible really to download. The gigabytes, terabytes, they're really not possible to download. And so if you really want to do some really in-depth computer vision, it's probably best to use an API. Okay? So did I tell you I work at Microsoft? I might have mentioned this previously. So I work at Microsoft, and we have another API called Computer Vision. She's still there. Computer Vision, really, really powerful API that you can give it an image, and it will tell you so much information about it. And one thing that it can tell you about that's incredible, I still today find scary, is that it will come up with a sentence, a human-readable sentence to describe the image, right? She's not my colleague anymore. She used to be my colleague at Microsoft. She now has moved to Netlify. But anyway, Sarah Jasner, my friend, created a demo to demonstrate this because she thought, wouldn't that be great for accessibility? We're supposed to put descriptions of images in alt tags in browsers. We know we're supposed to do this. We probably don't all do this, but we should be doing this. Wouldn't it be great if this API could just describe what's in the image and always put that description in the alt text, in the alt tab? Attribute. And that's what she did. She made another code pen to kind of demonstrate this feature. And again, you can go to this code pen and try it out. This is her default image she has in there. And then the text here is what the API returns. Okay? So it says, a black and white photo of Thomas Edison. The text says, hey girl, did you just share electrons because I'm feeling a covalent bond between us? Is that chemistry or physics? I don't know what this is. Is it funny? A little bit. Not really that. I don't really get it. But it's a default image, so whatever. And what blows me away about this is well, two things really. It didn't just say a black and white photo of a guy or a human being. It said Thomas Edison. It knows exactly who this is. And then it understood that actually what was most relevant about this image is to extract the text, so it could read the text as well. That the API returns that for that image. Pretty scary, I think. But as we all know on the internet, there are some very, very helpful people. And whenever you release something for free on the internet, some very, very helpful people always helpfully tell you everything you've done wrong. So these very helpful people then told her on Twitter some of the images it didn't work with. So for this image, it says a star-filled sky, and the text says for some characters, so obviously not right. The next one could be true. It could be true. I mean, they could be dead, stuffed cats. You don't know. Okay, you don't know. I like the next one, because the next one is, we're 50% right. We're 50% correct on the next one. Okay? 50% is a pass mark in my where I come from. So just to summarize, and if there's one thing you take away from this talk, one thing, is that TensorFlow.js doesn't have any dependencies. Okay? MobileNet is a really simple way to analyze images if you just want to do something quickly in the browser. It's how I start this stuff on my workshops. But if you really want to do some really deep image analysis, you probably should use an API or another service, and the Azure one is very, very good. Okay, last demo, my favorite. It's called Image to Image. Again, this is on AI.js Rocks. You can try this out. It works in the browser. So let's just watch it working. So you can draw the outline of a cat, and it will fill in the rest of the cat. Okay? It's called image to image. It's made by this gentleman, Zaid, who's based in Saudi Arabia. He's still a student. What was I doing at university? Not this. And it's really cool. And he uses an algorithm called pix to pix. And really it uses a technique called a GAN, a generative adversarial neural network. And they're very, very interesting tools. They've only really come out in about 2 years, maybe 2.5 years now. And hopefully you now know enough that I can teach you a GAN. Okay? That's what we're aiming for today. So a GAN is 2 neural networks that are fighting with each other. They're competing with each other. Okay? Number one, you have a generator. Okay? And another one is called discriminator. The generator's job is to generate cat images, filled-in cat images, from the outline of a cat image. So its job would be to fill in this image and output the image. But remember, when we create a neural network, we randomize the weights. So it's not going to do a good job at the start. It's just going to give us noise. Right? It's not going to do a good job. But it doesn't matter. We take all of our cat images that have been generated, and we combine them with real cat images. A bunch of real cat images. Okay? And we give all of those to the discriminator. And the discriminator's job is to be able to tell if an image is a real cat image or a fake cat image. Okay? That's its job. Let's say it did it wrong. Let's say it thought that this was a real cat image. We know it's wrong. What do we do when a neural network is wrong? We tweak it. We back propagate it. So then the discriminator gets better. But what if the discriminator got it right? Well, that means that the generator's not doing a good job. And the generator is tweaked. And what happens is as the discriminator gets better, the generator gets better, the discriminator gets better, the generator, and they fight, until eventually the generator is doing such a good job of generating cat images that the discriminator can't tell anymore, and then you know you've reached the end of the training, okay? It's doing a good job. We throw away the discriminator for our web work, because that usually requires a lot of computing. You can't train this stuff in the browser. Well, nothing as complex as this in the browser. But the generator, you can export that as JSON, TF-load model it, and use it from within the browser to do your own outlines. Okay. That's how it works. That's how it works, right? Pretty cool. That's how that demo works. But it doesn't just work with cat images. Yeah? Well, you can train it up on whatever you want. Whatever you want. This is another one. Now people are getting scared. I like it. So these are the outlines. Those images are generated from the left images. This is not a real image, it's computer generated from the outline. Okay? But this isn't the pix to pix algorithm. This is the vid to vid algorithm. Okay? Generated. This is not working in the browser yet. But as we know, especially with JavaScript, you have to put the word yet, because everything's changing. And it doesn't just work. It can work in multiple modes. So one input, multiple outputs. Okay? And it doesn't just have to work with outlines. The inputs can be anything. Anything you want. Okay? So for instance, this is another one with a segmented image. So the image shows depth. So this is the input, this is the output. She's not dancing. It's generated. Okay. How about this one? This is a car scene. There's a segmented image of, this is the input, and there's 3 different algorithms that are using to make the output. The bottom right is the vid to vid. Pretty cool, right? That's generated. And again, as I said, it doesn't just have to use... If I wanted to scare you, that was how I did it. So It doesn't just have to use segmented. It can take any input at all. The input can even be text. Just text. Okay? So there's another one. That's the only input into the neural network. This flower has long, thin yellow petals and a lot of yellow anthers in the center. That's after 600 iterations. That's after 1,200 iterations. Pretty good, right? This one maybe not so good, but the rest is pretty good. This is a bird one. This bird is white, black, and brown in color with a brown beak. 600 iterations, 1,200 iterations. That one's probably not that good, but the rest of them very, very good, right? How far away? 10 years ago, we couldn't tell the difference between a cat and a dog. How far away do you think we are from somebody just typing in, create a website, blue, title bar, these menu fields, make it an e-commerce website, PayPal payments, use these 4 images. Makes you 20 websites that you can pick from. Interesting. Just to summarize, so GANs learn to generate new images. That's the word generative in it. Most of neural networks that we create are discriminatory. They're there to tell you if something is one thing or another thing. Generative, they generate things. It's so exciting about them. They take a lot of computing power to train them. They're require incredibly large amount of computing power. But the generated model can be run in the browser. You can export it to be run in the browser. If you want to learn a little bit more, I am considering writing a book on TensorFlow.js. I haven't committed to writing the book yet. If I get 1,000 signatures, not 1,000, 100 people to sign up on this, if you go to the link and you find it, if you sign up for it, you just have to put your email address there. I'll then do a Kickstarter and see if anybody's interested. Leave it there for a second for everybody to take a picture. Okay, we're good. Okay, excellent. And if you do want to learn a little bit more, dip your toe a little bit into some of the stuff, and you want to learn how to build the Emojifier that you saw at the start, the Slack bot, you can go to this link there, and I have a full tutorial, step-by-step, everything you need to know in order to build your own Slack bot, which does some emojifying things. You doesn't have to put emojis on a face. Someone made it one where it puts glasses on people's faces, or it puts silly hats on. Doesn't really matter. Very, very useful stuff, though, for your work, of course. And that's it. If you want to find out more about me, or you can follow me on Twitter as Joik. Thank you very much for your time.
Thank you.
Questions?
Yeah, thank you so much, Asim. I think we will have a few minutes for the questions. I think you have a question, and not because of this great bag and you want to own. So please,
where's the money?
If someone have a question, just yep.
Yeah, hi. Thanks a lot for your talk. Maybe the question will be a little bit philosophical, yeah, but I want to hear your thoughts about it. As a human being, as a civilization, will we be able to build real AGI, artificial general intelligence, in the nearest future? Yeah, with this consciousness, free will, and so on. So, basically, your feelings, yeah, or is just some science fiction?
I think, well, personally, this is my personal beliefs in life. I'm not religious. I'm spiritual. I do believe that there's more to consciousness than just bits and bytes on a computer. So from that perspective, I don't believe it. And also, you saw how they work, right? The general purpose aspect of it isn't there. Right now, everyone's very, very specific.
Yeah.
Okay, they're very, very specifically doing things. There are things that the things that you can do with transfer learning, where you can take one and kind of convert it into something else, or work something similar. Personally, I don't think we're very close to that kind of. I try and scare everybody with this talk, but I don't think what you should be scared of is a general purpose AI. I think you should be scared of they're getting very, 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 very good at doing very, very, very specific things. Yes, right now, we've been very protected from this space. Other people haven't. Other industries have been decimated, right? We've been very protected, but we probably shouldn't be so confident where we are. So that's probably the fear that should happen.
Thanks.
Anyone else?
Thank you for your speech. What could you say about the performance? Could you compare the origin TensorFlow and TensorFlow.js?
Yeah. So there is a slide. I get asked this question every single time, and I keep on forgetting to put the slide in. But there is a slide that shows you that, okay, training is very computationally intensive, and it costs a lot of money. So you wouldn't normally use TensorFlow.js in the browser to train because you're just using JavaScript, it's using one thread, it's not really efficient for that. I will come back to that in a second though. So when you use Node.js, it's using TensorFlow proper. When you run it in Node.js, it is using proper TensorFlow. And then obviously you can run it using TensorFlow with the C application on the server side. Training is not very good. The other mode, which is once it's trained and you give it new data and you want to get an answer from it, that's inference mode. That's actually very fast in JavaScript. It's only twice as slow, which I know sounds very slow, but the number is it's like 1-2 milliseconds versus 2-4 milliseconds. They're very low numbers, so the inference mode is very, very fast. So once you've got a model that's been trained, using it in JavaScript is very fast. Now, when you want to train something in JavaScript, there is something that I think is quite interesting called transfer learning, where you take a model that's already been trained, and then instead of retraining everything from scratch, you only retrain the very last layer. It's like training. I describe it as taking, instead of trying to train up a JavaScript developer from scratch, taking a Python developer and retraining them into JavaScript. There's a technique coming called transfer learning. And that is now I personally think that's where it's starting to get very realistic to do training with JavaScript, because that doesn't require a lot of training. But yeah, so hardcore training from scratch, probably JavaScript is probably not your right route. But using a model that's been trained up is very equivalently fast. Yeah.
And the last one question, probably.
Yeah. Hi, thank you for your speech. My question is, you just said that it's difficult to train a model in a browser because it's single-threaded. Is it really possible to train a model in multiple threads, and how easy it is to merge all of those model changes into one big model?
I don't know. I know there are complexities because you can batch things up. You can batch. Even right now in the browser, when you've got a large data set, you have to batch up because of memory. There's not enough memory. So you can do that. That's a good question, actually, because you can use web workers and try and do something along those lines. TensorFlow.js, right now you can't, but I'll ping to them, and that's actually quite a good question, see if they would implement that. Yeah. Good question. Oh, go on, give them, let them go. Go on. You can't, it's a bag full of money here. I mean, you can't let the guy.
Hello, so thanks for the speech. So, excuse my ignorance, but so you said that Microsoft has these kind of APIs, right? And is it using TensorFlow in the background, or? I think not, right?
No, well.
So the question is, do Microsoft has a plan to open that like a TensorFlow.js or TensorFlow like a library to the public?
We have our own, which doesn't, I can't remember the exact, CNTK. So rolls off the tongue, very CNTK. I don't know. So we have our own called CNTK that is our own system for training. What our APIs use in the background, I don't even know.
Okay.
It's proprietary. They won't even let me know because it's our IP versus everybody else. I don't even really, I've asked them, they said. So, but fundamentally, at the end of the day, it's going to use one of those graph trees with something that you've seen there, but the actual technology, I don't know specifically, or even how it was trained.
And you don't have an idea, like it's going to be a public API, like TensorFlow.js that Google do, right?
TensorFlow is a public, it's an open source technology that you can use, but to do anything with it, you have to train it up. Yeah. And the big thing with training up is two things, is your data. Do you have good data? And have you spent the computational power to train it up? So even though TensorFlow is free, you have to do both those things to get usefulness out of it. With Microsoft, we've got the same thing with CNTK. It's free, you can use it, but you still need your data and you still need the compute. The advantage of the APIs is somebody else has already got the data and they've already done all the compute and is available to you with an API.
Thank you.
Yeah.
So guys, because we are a bit out of timelines, so you should probably choose the winner.
Oh, I think I should give it to the ethical question because that's an important question to ask, and it allowed me to scare the audience once more, which is what
Please
I like
take your
doing.
prize.